So we're starting linear functions. So what we're talking about are straight lines, and we're going to go over some things that you should have done in junior school in the first few lessons. So what we have here in this first picture is an interval from A to B. So if I want to know the distance from the point A to the point B, then what I do is use Pythagoras' theorem, which means we need the right angle triangle. So once I've made my right angle triangle, we need to figure out how long the sides are. So if you are looking at this point here, and I'm going to call it C, then the x-coordinate is going to be the same as the x-coordinate for B. So the x-coordinate is 4, and the y-coordinate is the same as the y-coordinate from A. So this is the point 4, 2. Okay, so if I want to figure out the distance AC, well, the y-coordinates are the same. This is a horizontal line. I'm going from 1 to 4. So if I do the 4 minus 1, I work out that this side here is 3. Okay, and if I want to work out the length of BC, well, the x-coordinates are the same, only the y-coordinates have changed because this is a vertical line. So if I'm going from 2 to 6, then this is 4 units. So from there, you work out your distance. So that distance squared, Pythagoras tells us it's 3 squared plus 4 squared, which is going to give you 25. And then I have to take the square root. So the distance, square root of 25, so it's 5 units long. So what I'm going to do now is generalize it. You will have seen this formula before, just going through the derivation so that we can all understand where it comes from. So I have these 2 points here, A, which I'm calling x1, y1, and B, which we're calling x2, y2. So because we're just generalizing it to any x and any y, this will be a formula that can be used for any points, positive, negative, any of the 4 quadrants. So this point C, similarly to what we did above, the x-coordinate is going to be the same as for B, so this is the point x2, and the y-coordinate, well, that's going to be the same as for A, so it's the coordinate y1. So if we then want to work out these distances, well, the point AC goes from x1 to x2, so the distance is x2 minus x1. And then if we want to work out this distance BC, well, that goes from y1 to y2. So this distance here is y2 minus y1. So then, using Pythagoras again, we know that the distance squared is going to be equal to, so looking at that distance AC, it's x2 minus x1 all squared plus the other distance, so that is y2 minus y1 all squared. But that gives me the distance squared, and I'm looking for a formula for just the distance. So the distance between the points A and B is given by the square root of x2 minus x1 all squared plus y2 minus y1. And that works for any 2 points. Now, it doesn't matter which point you choose as point 1 and point 2, because what you're doing is finding the difference between them and then squaring it. So in the example above, if you did 1 minus 4, you would get negative 3, squared is 9. If you did 4 minus 1, you get 3, and 3 squared is 9. So it doesn't matter which point you use as your first or second point, just make sure that you get your x1 and y1 from the same point, and x2, y2 come from the same point. Don't mix them up. I'm going to go through some examples now. So we want to find the exact distance. So as soon as you see exact, what is that going to tell you? That we're looking for a surd. Don't type it into your calculator. I don't want a decimal approximation here. Okay, give me an exact number and leave it at that. So find the exact distance from the point A, 2, 5, to the point B, negative 3, 0. So the first thing I'm going to do is choose my points x1, y1 and x2, y2. And again, as I said before, it doesn't make a difference which one you call which. Okay. So that's what I've decided my x1, y1 and x2, y2 is. You'll get the same answer if you work it out using b as x1, y1 and a as x2, y2. So I always want you to start with your formula. Okay, show them that you know what you're doing. So start off with your formula and then substitute in. So we know that we've decided x2 is -3 minus x1, so 2, all squared, plus y2, so 0, minus y1, 5, all squared. Now think about that. If we're going from the point 2 to -3, that's 5 units. So when we do -3 minus 2, we get -5. Just tells us it's heading in the opposite direction, but we're only talking about distance. Doesn't matter which direction we head in. So when we square it, it becomes positive and we don't have a problem. So then that ends up being the square root of 50. Now, if we want this as an exact answer, we're working with surds. So 50 equals 25 times 2. Which means the exact distance is 5 root 2 units. If they wanted you to do it as a decimal, you would then just type it into the calculator and give the decimal answer. Now, another example, in this case, instead of asking us to find the distance, they're telling us the distance. We have to work the other way. So you're still going to start off the same way. Start with your formula, then substitute in what you know. So if the distance between A3 and 811 is 10 units, find the value of A. So, as I said, start with your formula. So now we need to say, well, they've told us the distance is 10, and we know. Now I am going to call this point x2, y2, and I'm going to call the second point x1, y1. Now the reason I'm doing that is because then I end up with a minus 8 all squared rather than 8 minus a and having to deal with a negative. But it wouldn't matter, you're still going to get the same thing. So this is equal to a minus 8 all squared plus 3 minus 11 all squared. Now looking at that, I've got a square root. I don't know about you, but trying to work that out isn't going to be pretty, so I'm going to square both sides. So that leaves me with 100 is equal to a minus 8 all squared plus 3 minus 11 all squared. So the 3 minus 11 is -8. We square it, we get 64. And you're just solving an equation, nothing different to what you already know. Subtract the 64, so we get 36 is equal to a minus 8 all squared. Now, stop and think about what's going to happen here. If this is squared, we then need to square root. But remember, distance doesn't tell us about direction. Distance only tells us the length in between these 2 points. Now consider what's happening here. We know that we are 10 units away from the point 811. So we've got our point 811. We know that the y-coordinate is 3. And we know that we're 10 units away. Your problem here is that you could be 10 units in this direction, or you could be 10 units in that direction. Knowing that we're 10 units away only tells us the distance, not the direction. So we're going to have two things that we need to consider here, which makes sense, because if we're squaring it and getting 36, then we don't know if we started with 6 or -6. So you need to consider both options. So when you take the square root of both sides, you end up with two possible solutions, the 6 and -6, which means that a is either equal to 8 plus 6, so 14, or 8 minus 6, which is 2. So for the first exercise, I want you to do at least these questions you can see here. So 5, 7 to 10, 12, 14, 17, 19, and 20. You can skip the first few if you're really comfortable with this formula and you've been using it for a long time and you know exactly what you're doing. If not, you'll need to do the revision of those. So it's up to you, but you must do at least those questions. Good luck, and I'll see you in class.